A ship is moving at a speed of 30 kilometers per hour, parallel to a straight shoreline. The ship is 6 kilometers from the shore and it passes a lighthouse at noon. So let's go ahead and draw a picture. Okay, so here we can see that this is the ship, okay, and it is moving at a speed of 30 kilometers per hour and it's parallel to the shoreline. Okay, so here we have the ship and there is the shoreline. Now the ship is 6 kilometers from the shore and it passes a lighthouse at noon. So there's the lighthouse. Okay, now what we want to do is we want to express the distance S between the lighthouse and the ship as a function of D, and the distance the ship has traveled since noon, and that is find F so that S is equal to F of D. Well, the first thing we need to look at is that this creates a right triangle. So here is our right angle, and there is our right triangle. So what are the legs of the right triangle? The legs of the right triangle are 6 and D. And so what is the hypotenuse? Well, the hypotenuse is S. So when we have a right triangle, we need to use the Pythagorean theorem. So what does the Pythagorean theorem state? Well, that means that if we take one of the legs, which we can say is, let's say, x squared, plus the other leg, which is y squared, and that would equal c squared, which is the hypotenuse. Now, in this scenario, we know that 6 is a leg. We're squaring that. We know that D is a leg, and we're squaring that. And then it's equal to S, which is the hypotenuse, and we're going to square that. And so what we're going to do here is we're going to solve for S. So 6 squared is 36 plus D squared, which is equal to S squared. And now what we want to do is we want to solve for S. So I'm just going to rewrite this where S is on the left side of the equation. So we have S squared, which is equal to D squared plus 36. If we take the square root of both sides, S is going to equal the square root of D squared plus 36. But now you see up here we want to write S as a function of D. So therefore F of D is going to equal the square root of D squared plus 36. So now we've answered part A because we've expressed a function in that form. So now in part B it says express D as a function of t, the time elapsed since noon, and that is find G so that D is equal to G of t. Well, recall that when we talk about distance, that's equal to the rate times your time. So what do we know about the rate from our question? We know that the rate is 30 kilometers per hour. And we know that t is measured in hours. So we know that the rate is 30 kilometers per hour, and we're multiplying that by t hours. So what does that mean? That means we can eliminate the h, and so d is going to equal 30 times t. So therefore, it's going to be 30 t. So we know that d now has to be replaced with g of t. So therefore, this becomes g of t, which is equal to 30 t. So now part C, we want to find f composite g, and what does this function represent? So we're looking at f composite g of t, which is equal to f of g of t. And we know that g of t is 30t. And then we're going to plug it into the function up here, which is d squared plus 36. So therefore, that's going to become the square root of 30t squared plus 36. So that's going to equal square root of 900 t squared plus 36. Okay, now what does this function represent? Well, again, going back up here, right, we're saying that the ship is moving at a speed, right, of 30 kilometers per hour parallel to the straight shoreline. The ship is 6 kilometers from the shore and it passes a lighthouse at noon. So in this scenario here, we can say that this function represents the distance between the lighthouse and the ship as a function of the time elapsed since noon.